we are going to learn about module 5.5 now, and this is all about linear regression. So this is still under creating linear equations. Let's look at our learning target. I can write equations of best fit lines using linear regressions and determine how well functions fit sets of data. Okay, so in this there's a lot of calculator usage. Most of the lesson is based on the graphing calculators that are used a lot in high school, etc. And the vocabulary, we have plenty. Of course, we are talking about scatter plots, but we can see some of the vocabulary written down there. Where we have line of fit, residual, correlation, coefficient, interpolation, extrapolation. So these are all the words. A whole lot of this we have already touched in our previous lesson, and we'll talk about more about line of fit and what residual means today while we are getting in depth into our lesson. And once again, what is a scatter plot? A scatter plot is used to investigate the relationship between two different variables, and we learned about this in module 5.4. And of course, correlation is also called a trend, which means how the points in the scatter plot are related to each other. And again, we learned about this in module 5.4. So let's quickly talk about the best fit line. And a calculator can find the line that most closely approximates data in a scatter plot, and that is called the best fit line. So it's again most closely approximating the data in the scatter plot. And linear regression is one of the algorithms which is used to find a precise line of fit for a set of data. Okay, and so calculators can compute a number which is R, okay, which is called the correlation coefficient. And this basically, I'll come back to this in a minute. I just want to review what we did yesterday about correlation coefficient. So please look at this really quick once again. So our correlation coefficient, it goes from -1 to 1. Okay, and this measure shows how well data are modeled by a linear equation. It will tell you if a correlation is positive or if it is negative, as you can see on the other side, and or how closely the equation is modeling the data. And the closer the correlation coefficient is to 1 or -1, those are the perfect correlation coefficients. And because that's how, it's showing that the equation models the data more closely. When you come to 0, there's no correlation. Where you're having all the dots falling in about the same line, that's a perfect positive correlation. And anything 0.8 and higher are a very strong positive correlation. Okay, and then we have moderate, and then of course here we have weak, and then there's no correlation here, and then again the negative values again go the same way. Okay, it's strong over here, moderate, and then weak, and then no correlation. All right, so in both ends we can see we have a perfect negative correlation there, and we have a perfect positive correlation here. So if I'm asked that the correlation coefficient is shown by R, okay, and if I have something like this, and what does this mean? And this basically means I'm looking at 1/10, and we know this is 5/10, and so 1/10 is going to be somewhere here, right? So therefore this is pretty close to the no correlation. So what does this mean? This means that it is a weak positive correlation. That's what this means. Okay? What if I have a -9/10? Okay? So If I have negative 9/10, that is somewhere here. Okay, so this is here. So what does this mean? This is pretty close to the negative 1. And so therefore this is going to be what? It's going to be a pretty strong one, right? So this is a strong negative correlation because this is pretty close here. So this is going to be falling in this. It's a strong negative correlation. It's falling between negative 8/10 to negative 1. It is a pretty strong negative correlation. So now here are the examples of what I was just showing you as to based on R is equal to what. So we can see the first one. Look at this example, linear regression and best fit lines. So the first one is saying R is equal to 200. Okay, so that is pretty close to the 0 that I was showing you. So that is a weak, positive weak correlation. Let's look at a moderate one. So if I have 7200, so I was telling you that from about 5/10 to 8/10 is moderate, right? So this is a moderate correlation. As you can see, that they're closer together and it's going upwards. Here it's like all over the place. Okay, but here it's more clustered together. So if I was drawing a line through, okay, so this has a moderate correlation. And then this one, negative 9700, see most of the lines are almost, the clusters are almost together. So it's going downwards. So this is a strong negative correlation. So this is, these are 3 examples that I wanted you all to see. Now, so let's just quickly talk about a few more things. The vocabulary, we have a line of fit. And what is a line of fit? It is a computer generated line used to model the correlation between 2 sets of data. And so what we're going to do today, I'm just going to show you the steps on a calculator because that will also definitely create a line of fit for you. So once again, it's used to model the correlation. It's a computer generated line which is used to find the correlation between 2 sets of data. We have already talked about correlation coefficient and the residual. We are going to talk about that, and then we are going to calculate also. Residual is the difference between the predicted Y value and the actual Y value. So the output that we are getting. Okay, so it's basically the different, we are looking at the actual value and we're looking at the predicted value, and then that is, then we are subtracting that, and to get the relationship, the difference between the predicted Y value and the actual Y value is basically what residual means. Okay, and then we've talked about interpolation. It's a prediction where, you know, whatever is falling within the given set of data. Okay, so prediction where the ordered pair is falling within the data set, and then extrapolation is where it's falling outside the data set. Okay, and then of course let's go ahead, and I want to show you, just take this down and look at this. And once you have this written down and you practice this on the calculator, it goes really quick. When you are given your X and Y values, these are the calculator steps to use. Okay, so first you're going to enter the table of values. So you're going to hit stat, because this is all statistics. You're going to hit stat, you're going to hit enter, and then you're going to get a column. And you are going to use the X, and it, like by default, it goes into the L1 column goes for X values, and L2 goes to Y values. So for each X value that you enter, you will have to keep hitting enter, 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 enter to go down. So let's say I say 0, 1, 2, 3, 4, 5, 6. So that you're going to put on the X. And then whatever output I'm getting, the Y values will go into the L2 column. Okay, so that's how you first enter the table of values. In order to find the line of best fit, you then, after you have entered the values, you hit stat again, and then you arrow over to calculate, which is CALC, and you select for the fourth value down, which is, it says linear regression, and in this format, AX plus B, and then you hit enter. So when you hit enter after entering all this stuff, is pretty easy. When you start practicing it, you will see that when it's saying AX plus B, basically your A is your slope. It's like saying Y is equal to MX plus B, right? So A is your slope, B will be your y-intercept, and it will give you that r that we were talking about, which should be pretty close to 1 all the way to -1, right? So it's going to give you that r, which is the correlation coefficient. So let's go ahead and I'm going to show you an example. And using these steps that I just mentioned, so let's look at this one. Okay? So again, calculator usage for this, finding the best fit line, and we are looking at baseball. So the table shows Jackie Robinson's total hits during each season of his major league career. Use a graphing calculator to write an equation for the best fit line for the data. Then find and interpret the correlation coefficient. So what we're going to do, we are going to take our calculator and we are going to call here as X. So remember I said you to hit stat, then you have to put in L1, you put all X. So that's literally what we're doing. So if we think of 1947 as 0, this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's what I'm going to hit on the X table. Okay, and then on L2 I'm going to put the total hits. So for 0 I'll put 179, 175, 170, 203, 140, 185, 157, 159, 120, 81, 98. So these are my Y values. Okay, and then I am going to, so before I do that, you want to make sure that your diagnostic setting is on, and you can find this under the catalog menu. And when you press D and then scroll down, you will have to click diagnostic on and enter in your graphing calculator. Okay, but so let's see what comes up when you are putting all those values in. And then after you put the values in, once again you are hitting stat like I said, and you do the edit option and you're putting all of your the years that I just said, starting from 0, 0, 1, 2, 3, 4, from 1947 you're putting into X, and then the values into Y like I just told you. You will put it into a table format. Okay, and then after that, again I told you you're going to perform the regression by pressing stat, the CALC calc option, and then you'll do the linear regression AX plus B, literally what I had given you on the whiteboard, those steps. Okay, and then after that you're going to make sure that L1 is X list, and y'all, it obviously is very often it is default at that, but you want to make sure that the X list is L1 and the Y list is going to be L2. All right, and then after that you will select calculate, and when you calculate, this is what shows up in your calculator. So look, here is your Y is equal to AX plus B. A is my slope, B is my, because it's AX plus this is slope, B is my y-intercept, and R is my correlation coefficient. So it's automatically doing all that calculation for us. And then of course, if you have long numbers like this, you want to round to the 100th place value. So this would be -10, and 3200th is my slope, and then my y-intercept is 195 and 2200th. I am writing out the equation for this one. We know that we are writing it as y is equal to mx plus b, right? So y is equal to mx plus b, or in this case, what is it? Y is equal to ax plus b. That's how it is in the calculator. Okay, and so we are just going to go ahead and substitute the values that we have over here, and I have y is equal to negative 10 and 3200, x plus what is b? My b is 195 and 2200. Okay, so here is my equation set up like this, and then if I need to look at this, the correlation coefficient, that is a negative correlation coefficient. So this is about negative 8/10, which means that the equation models the data well. Its negative value means that as the years since 1947 increase, the total number of Jackie Robinson hits decreases. And that's what this basically means. So it is representing the data well because it is pretty close to that -1. The equation models the data very well. Okay, so when we are finding a best fit line, best fit lines can be used to estimate values that are not in the data. And recall that when we estimate values that are between known values, this is called linear interpolation. And when we estimate a number outside the range of data, it is called linear extrapolation. So you can also plot the graph based on the values that were given to you, and you know that the x list is L1 and y list is L2. So you will have to turn on the plot 1, and under stat plot you will see several types of scatter plots that are visible over there for you to choose and pick what kind of a plot that you want and how it should display, etc. And so then you click on stat plot, and then you can change the viewing window so that all data are visible by pressing zoom and then selecting zoom stat. Okay, and then you can graph the best fit line by you press y is equal to VARS, and that's what you're going to see on your calculator. You're going to see this. Okay, so you're going to see that, and then you're going to choose statistics, and from the EQ menu you choose your REGEQ. This is what you're going to see on the computer or on your calculator. And when you click on that, you press graph because regular equation, and it is going to graph it for you. So yeah, the graphing option is there also. But let's now quickly talk about our residual value. And what does a residual value mean? So when finding a best fit line, not all data is going to lie on the line exactly. Some will be above, some will be below, right? And now the difference between an observed y value and its predicted y value on a regression line is called a residual. So when residuals are plotted on a scatter plot, they can help assess how well the best fit line describes the data. If there is no pattern in the residual plot, then the best fit line is a good fit. So I am going to, without a calculator now, graphing anything for me, I am going to show you how to find the residual value. And let's say this is something that the calculator gave me, that this is my equation. All right, and so remember, residual means how far away are we from, how far away are we between our prediction and the actual value. Okay, so these y's over here, these are the actual values. So we are going to see how far is this from the predicted value, which is over here. So remember once again, this is my actual value, and then I'm going to try to find the predicted value by substituting, because this is what has been created by the calculator or it's computer generated for this table. Okay, so we are going to substitute the value of x with each of this, and we are going to subtract it from the actual value. So once again, for 10, what do I have? So we are looking at 10. Okay, we are looking at 10, and then we are looking at, these are my values, 10, 15, 20, 25, and 30, right? And then I am going to go ahead, and for this, what is my y? Okay, because that is my actual value. So I'm going to do 11 minus, and I've got 500, right? And times what? 500x. And what is x over here? It is 10, right? Times 10 and plus 12 and 6/10. And so when I solve this, I'm going to get -2 and 1/10. Let's look at the next one. This is what is my value over here? And so my y is how much? It is 14. So 14 minus, what is my x? So once again, 500 times my x, which is 15, right? Plus 12 and 6/10, and I end up with 6,500. Let's look at this value. And then what is my y? My y is 16. So actual value minus the predicted value. So this is my predicted value. Okay? And this is my actual value. So actual minus predicted. So 16 minus, we're going to take the input, which is x. And in this case, we have x is what? 20 plus 12 and 6/10. And I get my answer as 2 and 4/10. And then for 25, my actual value is 15 minus 500 times, what do I have as my x? It is going to be 25 plus 12 and 6/10, which is going to give me 1 and 1500. And the last one, we are going to do 12 actual value minus predicted value and times 30 plus 12 and 6/10, and I end up with -2 and 1/10. Okay, so once I have done this, I am going to put it on a plot. Okay, and so the first thing I need to know about a residual plot, this basically shows how well a linear model fits a data set. Okay, so that's what a residual plot is, showing how good it is fitting a data set. Okay, if I put this over here, and let's say we have 10, 20, 30, 40, whatever we have over here. Okay, example, I'm just giving an example. And let's say I have something which is here. Okay, there's one point over here, and then we have one which is going to be somewhere here. All right, and then I might have a little bit, here, and I might have something like this. So looking at this one, I can see that this is a good fit. This is a good fit. And let's talk about that in a minute. And then let's look at one which is not a good fit. Okay, so once again, I'm not putting any values, but let's say I put something like this, and then I have something like here. Okay, this is not a good fit. This is not a good fit. So let's talk about what is a good fit and what is not a good fit. Okay, so once again, a good fit is if it is close to the x-axis and randomly distributed above and below. So yeah, I have like doubled this, but if I had just shown it without circling it, and I was just trying to circle it just so that you could see it. But look how this is above and below the x-axis. All right, and it's randomly distributed above and below, and it's pretty close to the x-axis. So that's what makes it a good fit. Now, the reason why it is a good fit is because we know that the x-axis stands for the residual of 0. And that means that our actual data point matches our predicted data points perfectly. Okay, so when we go ahead and plot this one, so if I go ahead and graph this, let's look at this. When I had 10, what did I get over here as my output? Was negative 2 1/10, which is down here. Okay, then when I had 15, then what was my output? Was 6500. So for 15, it is somewhere up here. Okay, close, a little bit below this. Hold on. This is 1, so this is about 6500. For 20, it was 2 4/10. So for 20, it is somewhere here. Okay, for 25, it is 1 1500. So here. For 30, it is negative 2 1/10. So look like there's nothing which is like on the x-axis, and it's like not close together on the x-axis, and that is why I wanted to show you this graph, the residual plot. For it to be a good fit, it needs to be close to the x-axis and randomly distributed above and below the x-axis. Let's quickly understand interpolation and extrapolation. So I've just given some values over here, and going from 1975, then in fives to 2015 to the year, and then certain values given under that. So, and of course, the line of best fit is computer generated, and this is what has been provided to me. And so if we are going to predict what would be for 2003. So if you're going to predict for 2003, we are going to go ahead and see how far that is from 1975. And so this is going to be, this is 0. So 5, 10, 15, 20, 25. And then 3 more, so that gives me 28, right? So I'm just going to take this, and I am going to just substitute the value of x, which I said from 1975 to 2003. This is going to give me 28 plus 1345 and 400. And then when I simplify this, I get 2,685 and 4/10. So if I am looking at this, is it falling between or within my data? And as you can see that let's quickly talk about what is interpolation again. And we had said that interpolation is when it is falling, a prediction that falls within the given set of data. Is this falling within the data that we have? Absolutely. So this is an example of interpolation. So the prediction is falling. The prediction is falling within the given data set. Now, let's talk about an example using the same data, and we are going to find an example of extrapolation. Okay, extrapolation. What do you think that means? And that means if interpolation is finding within, extrapolation is a prediction that falls outside this given set of data. So if I give you an example and I say, let's find for 2019. Okay, so for this one, let's use 2019. And again, I'm going to substitute the values and I'm going to say y is equal to 47 and 8700. And since we're talking about 2019, so we are looking at this 5, 10, 15, 20, 25, 30, 35, 40, and then plus 4 is going to give me 2019, right? So what's my x value going to be? It's going to be 44. So this is going to be times 44 plus 1345 and 400. And when I simplify this, I am going to get y is equal to 3,451 and 32,000. Okay, so let's look at this set of value. What I have for y. Is it falling within this data range? It is not. It is falling outside. So therefore, this is an example of extrapolation. Okay, so this is basically what this entire lesson is about, and we are writing equations of best fit lines using linear regressions. And again, you know, a graphing calculator is very beneficial in that. And just follow the steps that I had given you in the beginning. And that concludes module 5.5. Have a fantastic day, everyone.